So let's move into section 10.6. In this section, we're going to learn the very important skill of solving equations. As we know, equations are a pretty big item in mathematics. It happens quite a bit. And so now that we're familiar with radicals and how to add them and subtract them and multiply and divide them, now it's time to solve equations with them. Before we start, we're going to first initially start with a problem with only one radical. I know this one has two, but they are like terms, so we're going to use that to our advantage here real shortly. What I like to do, though, is let's do a little bit of review, because it turns out that what we did in the past actually plays a role in what we're going to do now. So here's a linear equation with one variable in it. So the idea was to use the golden rule, right? We're going to do whatever we can to one side until we slowly pick away to the answer. So the golden rule of algebra is to do whatever you do on one side, the same thing to the other. So I subtracted 3 from both sides, divided by 2, and basically I isolated the variable x. And there's my solution. If I have two variables on each side, the idea again is we continue to use our golden rule of algebra. So perhaps I subtract 5x from both sides and add 7 to both sides. And we just keep whittling away at this until we get an answer, right? And so that would be the solution to that equation. So we're basically going to do the same thing with some little hiccups here along the way, and they're not too bad. So again, how do we get this square root by itself? Follow the golden rule. So I'll subtract 3 from both sides and get 2 square root of x equals 10. Divide both sides by 2. And in this case, we get the square root of x equals to 5. So here's where the radical idea comes into play, because it just seemed like we did exactly that. Notice we want to get x by itself. And right now what I have is the square root of x. So in essence, what we're asking ourselves is, what number can I square to get 5? Of course, algebraically, what I would do is just raise both sides to the second power, because that's what's going to clear the radical. Right? We've seen where a power, if it matches the index, things clear out. So we end up with x equals 25 as our solution. And pretty easy to check, right? If I plug 25 into there, right, we get 2 times 5, and we can see that 10 plus 3 does in fact equal 13. So that is truly the solution. Okay? So what do we do if we have a couple of them around like I do here? Well, thankfully they're like terms. So perhaps I subtract and I add 7 to both sides. This will give us a negative 2 square roots of x and would equal 16. Divide both sides by negative 2, and we end up getting that x equals negative 8. However, when I check this, right, we're going to have 3, the square root of negative 8 minus 7 equals 5, square root of negative 8 plus 9. And what do we know about square roots of negatives? They're no good. So despite all that great work, right, what we end up with is an extraneous solution. And since this is the only solution that came up, this equation would have no solution. So be careful here. We know that square roots have problems with negatives. So when we find our answer, we better make sure and go back and make sure that it actually works, or it's not extraneous. So be very aware of that. So, but the idea again is just keep on solving equations like we did way back when dare I say, math was easy. Adding a little bit more to the radical, here it is, and we're subtracting 5 from it. So mathematically, I'll add 5 to both sides, and I'll get the square root of x plus 8 is equal to 5. Now that I have my radical isolated, I can raise it to a power. In this case, the second power will get rid of the radical. So we're left with x plus 8, and over here equals 25. Do a quick subtraction, and we end up with a solution of x equals to 17. And of course, pretty easy to check. 17 plus 8 is 25. Square root of 25 is 5. 5 take away 5 is 0. So it does actually check out. It's not extraneous. Trying to throw another monkey wrench at you guys. Right? I have a cubed root, but the idea remains the same. Right? Let's get this radical by itself. I can accomplish that by subtracting 4 to both sides. Okay. This case, to get rid of the radical, I would actually raise both sides to the third power, and we end up with 2x minus 9, and I believe that's 64. And now we can solve for x. Add 9 to both sides, and we get 2x. I believe that's going to be 73. All right, divide by 2, and it looks like our solution is 73 halves. So to check it, to make sure that it works, I'd plug it in. That's 4. The 2's cancel out. We're talking about the cube root of 73 minus 9. This is 4, the cube root of 64, and I think we can see this is working, right? Cube root of 64 is 4, and 4 plus 4 is 8. So that truly is the solution to that equation. So again, the strategy, isolate the radical, and then raise both sides to a power to get rid of it. If it's a square root, we square both sides. If it's a cube root, we cube both sides. Okay, last problem here. I think we're good. Yeah, we're at 6 minutes. How about, I'm going to take a break and come back to this, because I actually want to do more. I just realized I made a little goofy error. So that should get us started. Let me do another round of this, and we'll pick this story up fresh and clean.